Hi, welcome back to the channel. Today we will be covering the most important aspects when it comes to working with the esp32 cam module. Whether you're using it for smart home integrations, some surveillance applications, or just DIY and experimentation in general, getting the best out of your images and video streams is essential. So let's get started. The prerequisite for following along with this tutorial is that you are already familiar with the fundamentals of an esp32 cam and you have managed to get it up and running. Topics that are going to be covered in this video are the power supply, Wi-Fi antenna, effect of lenses, different image sensors, casings and image processing with Python. Also, I have written a complete tutorial on instructables.com which goes along with this video. You will find a link to that in the video description. So first things first, let's talk about the power supply of that thing, which is the easiest step here, but still a crucial step for having a stable connection and a reliable and consistent performance of the video stream that comes from that module. Just make sure to always keep your power supply at exactly 5 volts. Theoretically, it could also run on 3.3 volts, even though that's known to cause connection issues. And applying higher voltages will just cause overheating issues without improving anything, simply because of the voltage regulator that's on board. Next up, improving the Wi-Fi connection by using an external antenna like that one. Be careful though, just attaching the antenna won't be enough. You need to move this resistor here in order to tell the board to stop using that internal antenna and instead use the external one. This can best be done with a pointy tip of a soldering iron. I'll be showing the effect of an external antenna in just a moment, but before I do, I quickly want to talk about lenses first. There is a variety of lenses out there which are specifically designed for the esp32 cam. In my case, I tested a 160-degree night vision lens which provides a wider field of view. On the left side you can see the stream from that lens, which is attached to a module with an external antenna. On the right side you see the stream from the standard lens, which is attached to a module without an external antenna. As a comparison, I included a video in the top center for which I used a webcam from Logitech, which is by the way the same one that I'm using for this main video. Its sensor has 15 megapixels, whereas the standard sensor of the esp32 cam, which is called OV2640, only has 2 megapixels. The webcam also has the advantage of being connected via USB. Even though I have chosen a lower resolution for the video stream on the right side, its images appear to be more vivid and clear. As a reason for that, I'm suspecting a low quality of the big lens. However, this is just my guess and I'm not sure of that. Also, you can observe some vertical flickering lines on the right side's stream. However, they disappear as soon as we attach an external antenna to it. Now, the standard lens is on the left side and the flickering lines again appear at that module without an external antenna. The esp32 cam typically comes with the OV2640, a 2 megapixel sensor. You can upgrade that to the OV5640, a 5 megapixel sensor for higher resolution. I also got that sensor with a 160 degrees lens, but when I attached it for a comparison, something strange happened.
something ain't right.
I briefly touched the back of the sensor and
Oh man, the building is on fire.
then I did some research and yeah, the 5 megapixel sensor is known to have overheating issues. Looking at the connector of the OV5640, you can see at the third connection from the top that a 2.8 volts power supply is required. However, I measured 3.3 volts at that pin. The camera sensor turns that extra voltage into heat, which I believe to be the #1 reason for the overheating issues. But the quickest way to deal with this problem was simply attaching a small heatsink to the back of the sensor. This was already effective enough. Now, going back to the comparison of the video streams. They roughly look the same and I sadly couldn't increase the resolutions any further, because then I always lost connections. And the different resolutions of the different image sensors is the main difference. Also, at higher frame rates, issues with the image transmission quickly arose. I'm not sure where the error is, but I've linked you another tutorial which focuses on a comparison of those two image sensors in the video description. Let's now completely change the topic and just quickly talk about stability through enclosures. A stable image sensor is crucial for quality. Without the proper casing, your sensor might shift around, which can ruin your image stability. Just like here, you can see the sensor wobbling around very easily, or with that module, it's even worse. So I recommend simply using a 3D printed custom bracket that encloses everything and you can attach it wherever you want to attach it. Finally, let's bring our images into Python. I applied some image manipulation functions which all work in real time, as you can see here. Let's take a look at the code. So this is the code. Crucial to understand are just those few first lines, because this is where we are getting the images from the stream into Python. We're just using the video capture function of OpenCV and we feed it with a stream URL, which consists of the IP address of your web server plus the port 81/stream. Then we're reading frame by frame and applying functions to it, and the rest of the code is just for displaying the manipulated images. I will provide the code in the tutorial on instructables.com that I have linked in the video description. I really hope you found this video helpful. Please consider giving a thumbs up and thank you for watching. Goodbye.